Calcium hydroxide is not the most soluble compound in water, but it does react with a strong acid, and hydrochloric acid is a strong acid. So at this stage of the game, we wouldn't expect you to know that. And in one of our tests, if you see a question asking you to determine the net ionic equation, you can expect both reactants to be soluble as well as react with each other. So let's write the equation for this reaction. Hydrochloric acid is HCl in aqueous solution. Calcium hydroxide, we can use the charges on these ions, crisscross the numbers, to find the ratios of how they combine. So the formula for calcium hydroxide is Ca, and there's two hydroxides. To determine the products, you can just switch the cations. So let's recombine the hydrogen ion with the hydroxide ion. Now these are going to combine in a 1-to-1 ratio, and you may notice this is H2O. It's water. But instead of writing H2O, I'm going to write HOH just for now, because it'll help us balance this equation. Now water is probably the only liquid you're going to see in a double displacement reaction. Now let's recombine calcium with the chloride ions. Again, we can use the charges on these ions, crisscross those numbers to get the formula. So the formula for calcium chloride is CaCl2, and that's soluble. Now let's balance this equation. You can see there's 2 hydroxides on the reactant side, only 1 on the product side. So we put a coefficient of 2 in front of the H2O, or the HOH. That updates, we have 2 H's there, and that corresponds to the H in the hydrochloric acid. So we need a coefficient of 2 in front of the hydrochloric acid. That balances out the chlorines as well. So we have a balanced formula equation. We know this is not the full truth because this reaction in aqueous solution, the strong bases, strong acids, and strong electrolytes are going to fully dissociate in water. Now, at this point again, if you see one of these problems on our test, you can assume that if it has AQ there, it's going to fully dissociate into their ions. But later on we'll learn that that's not always the case. All right, we're going to rewrite these with their charges and separated. Don't forget the charges on all of these ions. Now I move this 2 to the front because if we don't, it looks like a molecule, and we just want to quantify that there's 2 moles of OH for every 1 mole of calcium ions. If it's not a strong electrolyte, then we're not going to dissociate it. So this is where we can just write HOH as H2O. I barely fit all that in there. So this here is known as your complete ionic equation. So our next step is to eliminate the spectators. The chloride ions appear unchanged before and after the reaction, and so do the calcium ions. They're not part of the chemistry. So whatever's left is your answer. I spoke too soon because we need to reduce these coefficients. So now we have our final answer. And you should check that the mass and charges are conserved. In other words, the number of atoms are equal on both sides of the equation, and the charges are also equal on both sides. You got a positive and a negative canceling out on the reactant side, and you have no charge on the product side. So this is your net ionic equation for the reaction between hydrochloric acid and calcium hydroxide. By the way, this is a type of double displacement reaction known as a neutralization reaction.